Today we continue with the absolute value graphs again. So we're going to reverse the procedure. What we're going to do now is, given the graph, we're going to find the defining equation for that graph. And we're sticking to the graphs of this form at the moment. A absolute value x minus p plus q. So here's the first example. Determine the equation of the absolute value graph with y-intercept 10 and vertex point 34. Well, there we are. A absolute value x minus p plus q gives vertex point pq, so we now reverse the procedure. I would suggest you go along with me and pause as you go and try it yourself. So first step, we're going to take 34 and substitute it into that general equation there. So here we go. There we are. Y equals A, absolute value, x minus 3 plus 4. We've just gone literally and substituted back into the equation. Now, problem is to find the value of A. And we're going to do exactly the same thing as we've done with all graphs. If we have one variable in the equation still to find, we are always given another fact. Here you are, y-intercept is 10. So we're going to substitute the point 0, 10 into the equation. Try it yourself to get the graph. Solving that equation, absolute value of 0 minus 3, absolute value of negative 3 is 3. So we have 3a plus 4 equals 10. And that solves to a equals 2. We can now substitute it back into the second line here, where we put the value of 2, and there we are. There's our equation of that absolute value graph. The second one will go off the picture. Almost the same sort of thing. We're given the vertex point or the salient point, and we're given the x-axis intercept this time. Well, one of them. So we're going to take that salient point and we're going to substitute into the original. So there we are. Negative p says change the sign of p, so p is negative 1. So I go straight to plus 1. I don't put negative and then brackets negative 1. That's such a waste of time. And now we need to use the x-intercept to find the value of a. And that x-intercept is the point 50. So we substitute 0 for y, 5 for x, and we're going to simplify that equation to there, and solving we get a equal to negative 1/3. Substitute back into line 2, and there's our equation of this graph. So now, here's a point here. We're given the y value of the salient point, or the minimum value of the graph, and then we are given the x-intercepts, that alone. So we could actually substitute all three in and get three separate equations and solve for a, p, and q by simultaneous equations. But that's a bit of a waste of time, because considering that the absolute value graph is symmetrical about the center line, all we have to determine is the center line, and that'll give us the value of p. So there's the y-intercept. If we go up, from there, this divides the x-axis segment there equally, because this graph is symmetrical about this line. So now all we have to do is find the x value at that point. And that is, we just find the average. Add the two together and divide by 2. So there we are, x is 1. So we now have the salient point, the vertex point. 1 for x, negative 3 for y. And we're back to where we were before in the previous ones. Take that, substitute that into the standard form. Now we need to find the value of a. Take either one of those points. I always go for the positive value, unless it's a fraction. I always try to go the easy way around. That's what mathematicians do. We're pretty lazy, actually, but we always try to find the easy way around everything. So I would substitute the 3 rather. So I'm substituting 3, 0. You'll get the same result if you substitute negative 1, 0. So there we are. Substituted for x and 0 for y. Solving 2a minus 3 equals 0. A is 3 over 2. So we can go back to the second line of the equation, and there is the equation of this absolute value graph. And here are exercises for you. These first ones are taken from the textbook, and that there is actually a reference in the PowerPoint. If you go there, you'll find it will take you to the graph. It will take you to the video. If I log in here, there we are. And there it is there. Exercise 2B, exercise 2B, and there is our video of that graph. And that video covers both those. Then I've added just some extra going from the diagrams, so it's not a large amount of work for you. And in the PowerPoint, the answers follow. So try them yourself before you look at the answers, but the answers do appear as well, and that's where I sign out.